Hey class, Mr. H here. We're going to do 7.3, sum and difference identities. Here they are. These are the identities you'll apply in this section. The proofs of these are not required. There are proofs in the textbook if you're interested how these identities are derived. It's kind of lengthy, uses the unit circle, check it out, but it won't be required. One thing to note though is you might think, okay, that first one, cosine of A plus B, that's the cosine of just two angles added together, seems reasonable if that should equal cosine of A plus cosine of B, right? Cosine of each one. Turns out that's not true. If you picked some A's and B's and tried it, it doesn't work. So just careful of that. Don't misuse a false identity, but just stick to these and you'll be good. Okay, so the first type of an example we'll do using these is number one down here. Find the exact value of cosine of 105, right? Notice 105 is not on the unit circle. So we have to think about breaking up 105 so that we do have values that appear on that unit circle from chapter 5. So if you think about that for a second, 105 can be broken up into 45 plus 60, right? And 45 and 60 degrees, I know how to find exact values of those. So notice I didn't use like 30 plus 75 because those don't appear on the unit circle either. I want those multiples of 30 and 45 that then I can apply that unit circle. Okay, so now I'm going to apply my identity where here's your angle A and there's your angle B. Right, so go back up to your identity, which is the first one on that list. Right, and we're going to use this one right here. So I'm going to write this side, right? So let's do it. Okay, so this is going to look like cosine 45. So cosine of the first angle, cosine A, cosine of B, minus, unless it changes to a minus, sine of each one. Okay. And then now we're going to just figure all those out. Now you might have those memorized. Cosine of 45 is root 2 over 2, or look them up on your unit circle. Cosine of 60 is a half. Sine of 45 is root 2 over 2. And sine of 60 is root 3 over 2. Okay. And then from here on out, it's just cleaning this up algebraically. Right. So if I multiply root 2 over 2 times a half, that's root 2 over 4. 2 times 2, 4, minus root 2 times root 3 is root 6 over 4. Okay, and then now just combine because you have a common denominator, root 2 minus root 6 all over 4. And you can't combine root 2 and root 6. You just have to leave them separated. Okay, so there's the idea on those. Not too bad. It gets a little bit trickier on the next one because we have radian measure. There's a negative in there, right? So what I would do first is use a negative identity or even odd identity. It's what we call them. I could pop that negative out front because it's sine. So this is the same as negative sine 5 pi over 12. Okay. That helps. And then I don't have to worry about that negative. It just goes along for the ride for now. And then I would also suggest a radian measure, mental math. That's a little harder to work with. You can do it, but why not just convert this to degrees? You know, multiply 5 pi over 12 times 180 over pi, and you're going to get 75 degrees. So it's going to be easier to work with these in degrees. Okay. And then now break up that 75. 75 breaks up easily into 30 plus 45, which are both on the unit circle. And then now apply your identity. Just leave that negative out front. And let's see, sine of A plus B is this one, right? So notice the structure there. Sine of the first angle, cosine of the second, and then it just switches. Cosine of the first angle, sine of the second. Okay, I could do that. So it's sine of the first angle, cosine of the second. It stays plus, and then cosine of the first angle, sine of the second. Okay. Now, I guess I could have just used parentheses, but I used brackets. That's all right. Okay. I'm just going to leave that negative out front. And then sine of 30 is a half. Cosine 45, root 2 over 2. Plus cosine of 30, root 3 over 2. Sine 45, root 2 over 2. Getting those from the good old unit circle. Okay. And then this is going to be root 2 over 4 on that side and root 6 over 4 on that side. And then finally, I'll combine those and I'll just distribute that negative to the top, right? So that's going to be negative root 2 minus root 6, and then just write it all over 4. And we are good to go on that one. Okay. How about the next one? Find the exact value of tangent pi over 12. Okay, again, don't really like using radians. So pi over 12 multiplied by 180 over pi, 15. Okay, so this is the same as tangent 15 degrees, which breaks up into 45 minus 30. That's a nice one. Okay, so I'm going to use the tangent subtraction identity from above. All right, so how does that look? Tangent sub a minus b. That's this one. All right, so it's tangent a minus tangent b on the top. So that's tangent 45 minus tangent 30 over 1 minus plus, sorry, it's plus on the bottom, tan 45, tan 30. Okay, so unit circle. Okay, here we go. How about the tangent of 45? Remember, tangent is sine over cosine over y over x, right? The y coordinate over the x coordinate. If you're looking at that unit circle, it's at 45 degrees. X and y are the same. Sine and cosine are the same. So tangent 45 is 1. Tangent 30, you have the sine is a half, and the cosine is root 3 over 2. So just do a ratio of those, right? 1/2 over root 3 over 2. The 2's cancel, it's just 1 over root 3. Right. So I'm going through those kind of fast because that's chapter 5 stuff, right? And then down here I have 1 time the same ones, 1 over root 3. And it's better, honestly, to leave it as root 3 for now instead of rationalizing, because I'm going to have to fix that anyway with this complex fraction. Okay, so I've plugged in the values from the unit circle. Next, I need to clean this thing up. So this is all algebra from here on out. A good way to tackle this is to get rid of that complex fraction, multiply the top and the bottom by root 3. And then you can just distribute. That'll cancel out those fractions. Okay, so let's write that over here to give us some room. So if I do that distribution, it's going to be root 3 minus the root 3's cancel in the second term, and you just get 1. Over on the bottom here, we're going to have root 3 plus 1. Okay. And that looks good. I almost want to circle that as the final answer. However, there is a radical in the denominator. So if you have to rationalize this, we got to keep going. Let's just do that. Do you remember how to rationalize this type of thing from algebra? You multiply by the conjugate. Does that ring a bell? So I'm going to multiply the bottom by root 3 minus 1. That will get rid of that radical. And then I have to do the same thing to the top, multiplied by root 3 minus 1, right? So since there was a plus here, got to do a minus there. And then same terms. Now you're going to FOIL. So multiply that out. Let's just go right here. Root 3 times root 3 is 3. Outside is negative root 3. Inside is negative root 3. And then the last is negative 1 times negative 1 positive 1. Okay. And then we'll do the same thing on the bottom. We're going to FOIL. Root 3 times root 3 is 3. Now notice here the outsides and the insides cancel because You get a negative root 3 and a positive root 3. So we don't even have to do those. And then 1 times 1 is negative 1. Okay. Okay, cleaning this up, we're going to now have on the top, I can combine the 3 and the 1 as a 4, and combine the middles as a minus 2 root 3. Okay, and then in the denominator, 3 minus 1 is 2. Almost there. So now I can cancel. Since, you know, the 4, the 2, and the 2 are all divisible by 2, you can divide them all by 2. 2 divided by 2 is 1. 2 divided by 2 is 1. 4 divided by 2 is 2. Okay. Finally, what do we got here? We have 2 minus 1 root 3, which is just 2 minus root 3 all over 1. I don't have to write over 1. There. Whew. Final answer. I'm tired. Okay, so that was a lot of algebra. The trig part's not that bad almost, right? That's the algebra that can kind of kill you on these. So hopefully that rings a bell back from your algebra days. You'll just have to practice it a little bit. It'll come back to you. Okay, I'm going to end there for now. That's page 1. We'll continue with the rest in the next video. Hope all is well with you. I'll talk to you later.